Hi, I'm Mrs. Van Loo, and this is Computer Science for Innovators and Makers. We are looking at outputs. We've been working with inputs and outputs with our microbits, and now we are looking at outputs. We have 5 assignments to do, and we are picking up on this video with assignment number 4 for the standard servo. When you open up that assignment, you will see a document attached, and that document looks like this. It's called Outputs for Standard Servo. And I want to point out, as you begin working with servos, you'll observe that they allow you to provide movement in the environment in which they are used. Therefore, they're considered actuators. Actuators are a type of motor or servo that's responsible for moving or controlling a mechanism or components. A word of caution, you should never connect the 3V and the ground pins in your microbit using an alligator clip wire or any other kinds of wires, and you should be careful when you're working with loose wires on your desk. So starting with step 1, you would import the 2_2 standard servo.hex file into the MakeCode environment, and that works like this. I'm going to start with clicking on that underlined blue text. I'll click on the file name and then I'll click download. Now this is putting this file into my downloads folder. I can close this tab when I'm done with it. And over in MakeCode, this is what you're going to do. So I'm in MakeCode, I'm signed in. I'm going to click import, import file, choose file, and then you might find it in your recents if that's easier, but I'm in my downloads and it's the only full file in my downloads. So I'm going to open this and click go ahead. And in MakeCode, I can see that here's an error message. This may or may not work, but we will find out. We'll try this in a second. The program says on button A pressed, servo right pin P0 to 180, and then pause for 1 second or 1000 milliseconds. And when I press button B, servo right pin P0 to 0 and pause for 1000 milliseconds. So it is telling me that when I press button A, if I look at the emulator, it goes like that. And if I press button B, it goes like that. So this is what it's showing in the MakeCode coding environment, but I want to see what the assignment says to do. It tells me I'm going to need 3 alligator to pin wires, a standard servo, and a single horn. I'm going to show you what all of those things are with a real life connection. In just a minute, I will show you what these look like all connected together. In the past, we have talked about how alligator clip wire colors and jumper pin wire colors do not matter. Now that we're using the servos, this is the first time that the colors of the wires matter. So looking at the servo itself, it will say either standard servo or micro servo. And looking at the colors of the wires themselves, these are the colors on the servo. So this servo has a yellow wire, an orange wire, and a brown wire, and the places where those are connected on the microbit is important, which is what it talks about in this next section. And I'm going to show this to you in real life so that you can see it. And then we're going to look at what happens when this is downloaded to our microbit and when we press the A and B buttons. So I'm going to show you that now. In the directions it says connect 3 alligator clips to your microbit, and it talks about if you have certain colors. I don't have certain colors, I'm not worried about certain colors, but I want to start by showing you these special wires. I have these wires that are an alligator clip wire on one end, and they are a jumper pin on the other end. You might not be able to find any of those wires that are available right now, but if you can't, that is okay. So I want to show you what you could use instead. I could use a regular standard alligator clip wire like this with a regular standard jumper wire like this, and I could connect the alligator clip wire to my microbit, the other end of the alligator clip wire to the jumper wire, and then I could use the jumper wire in my standard servo, and that would be totally fine. In the directions, it says that we should connect the
the yellow wire of the standard servo, the yellow wire of the standard servo should go to pin 0. So I want to show you that that's what I have here. The yellow wire on the right hand side is going to pin 0 on my microbit. The red or orange wire in the middle is going to 3V on the microbit, and the brown wire on the standard servo is going to the ground on the microbit. In the directions, it says to alternate pressing A and B to see what happens, and I want to show you that right now. I also want to point out that I don't have a single horn. This is a double horn, so I just put a little piece of tape on that so you can see what happens when I alternate pressing A and B. So when I press A, can you see it turn? And then when I press B, it turns back. If I press A again, notice that nothing's happening. If I press B, it turns back, and if I press B again, nothing's happening. So again, A, it turns one direction, B, it turns the other direction. You could say that A is turning counterclockwise and B is turning clockwise. In your assignment at step number 4, it says alternate pressing the A and B buttons, what happens? And that's what you're going to write there.
And remember, we want to write down what happens when you alternate pressing the A and B buttons, and you're going to put some text right here in this text box. Scrolling down, it says a standard servo moves only within a certain degree range. This servo has the capability of moving a range of 180 degrees, where 90 degrees is the midpoint. Add another on button pressed block from the input drawer. Set this to the A plus B pressed box, then add code blocks to make the servo stop at the midpoint. Let's look at that. If I take this and I use 2 fingers on my trackpad, I can actually duplicate this. And then I'm going to change this, like it said, to A plus B, and it said to make it so it stops at the midpoint. So 180 makes it go all the way to one side, 0 makes it all the way to the other side, and it said 90 degrees makes it stop at the midpoint. So once again, if I click A, it goes all the way to that side, B makes it go all the way to that side, A plus B makes it stop at the midpoint. So we just did step 5. We tested our code using the emulator, and then it says to save our program using a name that makes sense, download it to our microbit, and test our new program on our microbit. How did you change your program? Did your new program work like it expected? What happens when you press A and B together? So what you're going to do next is consider what you have put here on your code, and then you're going to download this to your microbit, and we'll go over in a minute and look at the microbit and see if it stops at the midpoint like we expected. So A, B, and A plus B.
Okay, I have downloaded that program to my microbit, and I have the program that says that when I press button A, it will write pin 0 to 180. When I press button B, it writes pin 0 to 0. This is pin 0. And when I press A plus B together, it writes it to 90. We looked at it in the emulator. Now we're going to look at it in real life. If I press button A, it goes all the way to the one side. If I press button B, it goes all the way to the other side. So again, A, B, just like before, but now if I press both at the same time, it goes to the middle. Now this is overshooting just a little bit, but it is going to the middle. So you're gonna write about that in the assignment. In the second box where it says, how did you change your program? You added the A plus B program, and then you saw what happens when you press A and B together. So write about that in the assignment as well. The final question in the assignment says, what are some things in your daily life that might be controlled by a standard servo? And what I want you to think about is, What is something that has a motor that goes back and forth? So back and forth, back and forth. What is something in your daily life that you can see and observe that goes back and forth like that? If you're stuck on that, come talk to me and we can think it out together.